I just asked like if anybody want to contribute or maybe help me in writing the code by sharing the screen, or do I have to run my way?
Yeah, Babala, I'm sharing the screen. Yeah. Yeah.
Yeah. Can you check? Let's just write import CV2, import space CV2, and let's. Can you run that single line and see if there is an error? Yeah. So now, so guys, we are gonna deal with a library called Open Computer Vision, which is like which is in short form called also as OpenCV. So this is a open source module which can play with images, and also it also has a lever like what powerful methods which can also predict your face and other things. So we may not get into more of like what predicting faces today, or maybe identifying human beings, or maybe all the stuff. But let's at least do basic image manipulation, or if time permits, we'll also see basic face detection thing. Okay, so it might be very cryptic today. So having like if you can show more interest, we can discuss more. Okay, that is like as we also have less audience, I would rather recommend that you kind of be more interactive, because this is gonna be little away from our regular things. So I strongly recommend that you like what show some uh, interest. I can say curiosity rather than interest, so that you can better get into the stuff. So Mansi, as we all we we are gonna see image manipulation techniques. So last time when we had NumPy class, we had seen different uh, ways of working with multi-dimensional arrays. Okay. So then we have received the feedback saying that like when I have been asked the question where this has been really used, then I said, okay, when you want to work with images, if it is black and white image, we'll have a single two dimensions. When it is a color image, we'll have three dimensions, and an image is possibly a like each pixel has a value of the shade of these three dimensions together, that will combine and form a color. And we thought of seeing that in action, like how three dimensions of colors will actually combine to one image or one pixel, and how to manipulate those pixels in an image. Or maybe assume that you want to kind of put some other image in this image, how do you put that? Okay. Or do some abstract painting, and so on. So these things can be done. So all the background basics is NumPy. So now what OpenCV2 will do is basically it will leverage NumPy usage, take images as input, and basically transform those images into required outputs for us. Maybe you want to see the image in only one dimension of red color, or maybe you want to kind of completely manipulate, or maybe you need to rotate an image completely. So how do you rotate? So you you kind of use transpose in NumPy, which converts rows to columns and columns to rows. That is where you rotate. So that things also we'll see here today, and so that we can better understand how basically matrices work, how NumPy can deal with matrices, and how images are manipulated using this powerful package called NumPy, and how it is using OpenCV as a library to manipulate all these images. That is what we're going to see today. Am I clear, or is it something I want you need some elaboration? Yeah, great. Yeah. So uh, who is sharing the screen? Is it okay, Manjula? So can you kind of so you can already see that you don't have OpenCV2, right? Nothing but that CV2 library you don't have. So what you can do, I think you already know. So you need to go to Anaconda Navigator, check on base. Yes. Yeah. So go to environments. Yeah, and check for OpenCV2 or OpenCV simply, or CV as well. Nothing is. Yeah, OpenCV, just take it and then apply below. That's it, and it will install basically in few minutes. Yes, every tool in Navigator, every ID in the Navigator. Yeah. So this is the importance of using Anaconda distribution, because it can do all the things. Most of the manual things, it is automated already.
So basically, all these libraries work for the same or different?
OpenCV is what we are trying to use right now. Okay, so the description has been given same, but depending on like what need we have, each of those libraries will have different syntaxes. So right now we only need OpenCV, so we are taking that in. And meanwhile, while this is installing, can you download any one of the any image from Google, if possible? Like go on to Chrome. Yeah, take a new tab. Take any image, preferably any random animal image, or any human being image. Anything will fine. Yeah, you can just copy that image for now. Oh, okay. Let's do one thing. Let's take free images. Let's not use this all stuff. We might get into copyright issues later. Let's take free images. Yeah. Yeah, free images will be fine. Anything. Go to images and then just, yeah. No. Go back. Yeah. Okay. Let download any one of these images. This will be also fine. Save image as, and save it in your download section for now. Yeah, just save it there as maybe image dot. Yeah. Okay. Let it be fine. And can you go back and check if that is installed? Yes, now it is installed. Now can you see and run this line again? Yeah, now it is working completely good. So now what we can do? So guys, earlier also we have seen that we always write import pandas as PD. Like we always give some alias because the name itself is big. Right now in line number 9, the name itself is CV2, very small name. I don't want to give any name. Still, if you want to give some name, you can use import CV2 as C or CV or so on. Okay, so currently, like taking a single character does not help much. Okay, because C might be anything to like what in your code down the line. So I would prefer to keep it as CV2, but if you wish to kind of add an alias, it's up to you. You can add an alias. Okay, so Manju, coming to the next line. Let's try to read the image and print the image first. That is our first requirement, whether we are able to read the image or not. So you can take any variable, initialize any variable. Let it be A, B, C, D, or maybe image equals to, or img equals to. That is more better. Okay, let's take it as img equals to. Yeah, cv2 dot imread, imread, imread. Okay, in brackets, you need to give the path of that particular image which you have downloaded. So can you go back to downloads and use command option C? Command option C. I think I see you are on Mac, so command option C to copy, and just put the same here on quotation marks. Everything all together. Just cut and paste in quotation marks, and you have double quotation marks at the end. Just send it. Yeah, and you also give R at the beginning. So I always tell you that we need to add R to kind of tell it is relative. Yeah. So now what we kind of say is, let's kind of in the next line number 12, let's simply print cv2 dot. No, cv don't print. Just write cv2 dot imshow, imshow, imshow. So what we are simply doing, we are reading an image and we are showing an image, something like matplotlib library only. So we are reading the data and we are saying plt.show in matplotlib library. Here we are saying cv2.show. That's it. Okay. And then in next line number 13, then you say cv2 dot wait key, WAIT, capital KEY. Just put K as capital. That's it. Capital KEY, capital K, small ey, and in brackets 0. So what exactly this line will do is, it will pause the execution of the script until we press any key on the keyboard. Okay, we basically pause the execution of the. Why we need to pause the execution? Because we want to open a different window which shows an image, and we want to only close that particular window. Okay, when we want to kind of end the script execution. Okay, so now can you run this 4 lines of the image? What? Okay, so inside imshow, I missed. Okay, my bad. So can you kind of pass on the variable called image, img, which we have missed. So we said that show something out, but we did not say what to show. Okay, missing argument. Oh, okay, my bad. So just can you write before img? Yeah. So just write in quotation marks. Write any name. So like give any message. Yeah, it's fine. Yeah, and comma image. So it is basically the name of the window which we want to provide. Let's run this again. And then somewhere some window has to open. Yeah, you have the window open, right? So you see that this image has been opened by your spider window, and you can see on the top that Manju name has been presented on the very top of the window in the center. Okay. So now what we have done, we were able to only see a basic function, how to read an image, how to show an image. Okay. So what else we have to do? Now we can also try to understand. So the first basic thing which we learnt in NumPy, first basic thing when we understood what is an image is, image has 3 different dimensions or 3 different channels, I can say. Each channel has 2 dimensions, nothing but X and Y dimensions in each channel. And like we have 3 channels, which is RGB. I want to see if that is correct. Okay, I want to check whether this particular color image has 3 channels or not. That is my ultimate question. So now what do I do is, before cv2.imshow, in after line number 11, yeah, you can write one more statement saying print in brackets, okay, image dot shape. And we have seen this image dot shape, like we also saw for matrix. Okay, so when we have given an array dot shape gave us what is the dimension of the that particular array which we have given, or the matrix which we have given, whether it is 1 dimension, 2 dimension, 3 dimension, and so on. Okay, so right now I'll say okay, let's print image dot shape, and then we'll see what happens next. Can you rerun the code again, please? No, you need to rerun everything. From import CB2, yeah. Here the okay. Can you go back to the image where you have image? Just press some key here, or maybe close this particular window. Yeah. Wait. It is kind of getting closed, I guess. Can you go back to Spider window right now? Yeah, it got closed. Okay. So now you can see that there is what you got some output, which is a tuple. Yeah, inside tuple you have seen,
Okay.
and the first is 1280, 1920, 3. Nothing but the first is width. Sorry, first is height. 1280 is the height. Okay, 1920 is the width, and 3 channels. Okay, so just see, always we kind of go by convention, width, height, but here it printed different. Like it started with height, width, and channels. Now you can see there are 3 channels. Okay, nothing but those are RGB channels, red, blue, and green channels. And this is the height and width of the image. So this is the pixels with height and width of the image. Nothing but the pixel is 1280 pixels height and 1920 pixels width. That you can also cross confirm by checking the info of the image. Manju, can you go back to the image? Go back to download section. Especially go to download section, and can you right click on this, and then there is an option called get info. Yeah, click on that, and you can see the dimensions of the image. So in more info down, okay, there is a small section called dimensions. Yeah, just expand that. Yeah, you have a small thing called dimensions, and you can see what is the width and height. So here you can see the width and height convention is different, starting with width and then height. The output which we got starting with height, then width. So need not confuse that it is reverse. It is correct. The convention is different. That's it. And you can also see color space is RGB. Okay. So we also got the same thing because we have 3 channels, and the image itself has 3 channels. Okay. Is this clear? First 4-5 lines. Any doubt here? Yeah. Great. So now what we kind of want to do is we want to kind of manipulate this image. Okay, so we now have 1920 pixels in width, 1280 pixels in height, and what we want to do else is we want to kind of work with those pixels. We want to do something with those pixels. Whether you want to kind of rotate those pixels together, or maybe you want to completely remove those pixels, delete those pixels, okay, of one section and so on. So before even doing that, you know how to do indexing, if I'm not wrong, because we have already seen how to do indexing in 2-dimensional arrays in the last class, right? Yes. Okay. Fine. So let's see right now. Let's do a small thing here. Okay. Let's try to print. Okay. Image of img of 0, 0. Let's see what it prints. Okay. Of nothing but you need to give square braces because we are indexing, right? So square braces is something which we need. Yeah, both of them will be square braces. Yeah, and now you can run this everything again. And now you see what happens. You got 34, 35, 15. What are these 3 values? What is 34, what is 35, and what is 15? So basically these are the values of what is the red color, what is the green color, what is the blue color. Always we kind of go with RGB. Okay, so this particular that is the intensity of each color, that is 34, 35, 15. But what is the range of this color? Okay, so we want to understand what is the range first. To understand that pixel is of this intensity, you want to know that uh, 34, what is the minimum of 34? What is the maximum of 34? Nothing but how minimum the 34 can go or how maximum the 34 can go. Okay, to kind of show full color. So let's say if 34 is red, okay, so it is very small intensity of red. So what is the maximum of red? What is the minimum of red? So by convention in OpenCV, we'll have values from 0 to 255. You can write this somewhere as a comment, please. So every color has the intensity from 0 to 255. Okay, to give a small example, 0 means pitch like what pitch black, and 255 means pitch white. So when you say red color also lies in between 0 to 255. So 0 is very, very, very light red, or you can assume it to be also white. Okay, 255 is very dark red. Okay, so that is what the convention is. Okay, so I can also provide you some other inputs here. Okay, let me say something here. I'll put some inputs on the chat, Google Meet chat. Can you please copy that and paste it in our window? And just all of these are just put them all in quotation marks, or like triple quotation marks, so that it will be considered as yeah, comment. Okay, so now here you can see a very close, like what, if you can observe very close. So what are the values of black? So black values are 0, 0, 0. Nothing but if R red is 0, if blue is 0, and if green is 0, then you will have a pitch black pixel. Nothing but everything will be black. Okay, in the same way, if you have 255 as a value in red, 255 value in green, 255 value in blue, then the whole thing will be white. In the same way, if you want a complete red pixel, then you will only have 255 in red, and remaining 2 will be 0, 0. Okay, and so on. You can see other colors. What are those? Okay, and you can see also the later part. Aqua color is combination of green and blue. Okay, and we have one other color which is fuchsia color, which is a combination of red and blue. Okay, then we have maroon, okay, which is half of red. Then we have navy, which is half of blue. Which then we have olive, which is a combination half red and half green. Okay, we have purple, which is half red and half blue. So you have other two colors as well. You can check out. Okay, so this is the color this is the color combinations which we do to get those colors. Okay, nothing but these are the like what proportions of colors which we combine to create these new colors. Okay, or create their independent colors. Is there any doubt in these colors or the notation which I provided? Because before going further, there should be no doubt in this particular section especially. I can take silence as no. And moving further. So the next step, what you want to do is, I want to kind of change the color of the first pixel. So which we have already seen that the first pixel has 34, 35 and 15. Okay, I want to completely change the 34, 35, 15 to 0, 0, 0. Let's see what happens. So now what we can do, after line number 13, can you please write image of 0, 0 equals to outside the square brace. Yeah, so just write in tuple, yeah, 0, 0, 0. Okay, right? So now can you kind of run this particular whole thing? No, that comments is not required. Like you can run until line number 17. Okay, let's go back to our image. Image might be now showing. Okay, can you yeah, can you go to the leftmost top pixel? You might have to see black color. Leftmost top. No, you need to right drag the image a little. Just yeah. Okay, it is already okay. Can you zoom in a bit in the image right now? Zoom in a little. You can also use the yeah. So again, now pan it towards the topmost pixel. No, the pan nothing but the image itself. You should drag because you have zoomed in. Okay, you need to drag the image itself, like on here itself. Okay, here inside the image itself, you kind of drag the image towards right. Drag it. Don't zoom out. Drag it. Huh. Drag it. You are zooming in. You are not dragging it. Yeah. You need to drag it towards leftmost top pixel.
How?
No, no, no. You are in the middle of the image. Yeah, left. Yeah, left top corner. Go inside the image. Put your cursor on the image. Okay. Now click on that and drag to the right. No, don't select anything. Click on that and drag to the right. Yes. In the same way, just go on. Yeah. Good. In the same way, go on to the leftmost top corner. Yes, you are there. So we are almost there. Just go a little more. Absolutely there. Yeah. And you have zoomed in a lot, which you are panning a lot. You can zoom out a little and then pan the same way so that you can go back there and zoom in back. You can zoom in, like zoom out little more so that it will be easy for you. There are options for you to zoom out as well on the top. A magnifier symbol, yes, you can use that. Isn't it working? Yeah. And now pan the image to leftmost top pixel, like pan it. Click on the image and then yeah, move exactly. So go back onto the top. Okay, now zoom in a little, like now zoom completely in where you see the numbers. Yeah, now pan it again to see the first leftmost top pixel. You are zooming out again. Yeah, now pan it. The number should be shown and then pan it. Yes, the same way. Just pan it a little more until we reach the top. Actually, this is for understanding. We can actually group the images. Group few pixels and make it 0. But I want to kind of work with one pixel and show that it is 0,0, the very first pixel. You can see the very first pixel on the top is very pitch black. Okay, remaining pixels have some values, but the first pixel has 0,0,0. Can you zoom in a little, Manjula, if possible? There itself, only at the pixel. Yeah, again, can you pan it again to only show 0,0 especially? Yeah. So now you can see that what we have especially done inside an image, we have manipulated the image and we have removed the values which it was having like existing values, and we have replaced it with 0,0,0. Is this clear?
Yes.
Any doubts here? I am hoping no. Okay. Yeah. So now go back to the image again. We could also see this like what print by simply printing again print image 0,0. Okay, in line number 15, because we have manipulated and then we are checking what is image 0,0. But still you might have some confusion. That is the reason I have like what took some time to show that particular pixel which converted to 0,0. And now what we can do next is we can kind of group some pixels together and then change their color so that it will be easy for us to understand more. Manju, can you run this and again we'll add some more lines to this. And the image is still open, Manju, so that's the reason it is not running. Can you go back, click some icon on your keyboard or close this and then go back and now rerun the statement. The image is still open actually. Did you run multiple times?
Yeah.
Okay, go back. There is a red color stop button on the right hand side inside console, on the console bar. No, here itself on the console bar. Yeah, just click on that. Let's wait for a second. It will kind of exit. No, it will just terminate that particular like it will stop executing whatever it is, and then we can rerun the thing. If you like what click on the cross symbol before the console 1 by A, it will completely terminate the session, and you need to again, like, the new session will be recreated, and now you can run this again. And now you can see the output. Can you go back to the section? Now we need not see the first pixel, not required. Yeah, so you can see firstly the dimensions, then the existing colors 34, 35, 15, then the manipulated color of the pixel, which is 0, 0, 0. So these three things we were able to do. So now what we'll do? Yeah, sorry. Yes. That is what we did, right? So initially the top left corner of the cell has red value of 34, green value of 35. Yeah, so then we converted that to 0, 0, 0, so it became pitch black. So now to kind of see that in more action, what we'll do, we'll kind of change the color of at least some 1000 pixels, or maybe some 100 pixels or 200 pixels. Okay, so let's take one corner as a thing. You can in line number 16, you can do corner equals to and img of you can say how many pixels? Let's take 150 pixels. So 0 colon 150 comma 0 colon 150. So in last class, we have seen how to slice a particular matrix. So first will be the row slicing, the second will be the column slicing. So firstly, we are slicing 150 pixels in the row, and then in comma 150 pixels in column. Okay, yeah. So Manjula, just give a comma, and then again 0 comma, sorry, 150 comma 0 colon 150. Now I want 0 colon 150, not 150 colon 0. Yeah. Great. So now in the next line, you do the same thing again back, saying that you want to you want to kind of change. Okay. Why we are complicating it? Can you remove the variable in line number 16? Remove corner equals to completely. No, only corner equals to, not the entire line. Yes. And then here you just write equals to after in line number 16 itself, yeah, equals to, and then you assign any color, which will be, you can take black, red. So you have some colors down, right, from 22 to 31. You can give any value of one color. You should not write green. Instead, you should pass on the tuple value. So in brackets, just say 0, 255, 0. Yeah, that's great. So now you can again run this thing, okay, so that we can see the output. Actually, the image is still open, Manju. So you need to again close the image. Still the console is having the execution running. Close the console. Yeah, let it. For now, let's close. Later, we have a method how to kind of come out of the situation. You can see that a pitch green has been occupied by the top 150 pixels. 150 by 150 pixels. Okay, so this is how we do image manipulation. We are not directly using numpy.array, take 0 to 150 and so on. But when you say image of 0 colon 150 comma 0 colon 150, it probably calls numpy to read the image and then cut down those pixels, then apply this tuple as a value of some color. So that is what happens background. Okay, we won't be seeing it in live, but that is what happens in background. And you can see most of the things which we do in NumPy are similar in OpenCV as well, where kind of how the way you slice, the way you read a picture, like the way you see the dimensions of a image. Like you can simply use image.shape to see the dimensions. Even there also in array or matrix, you simply say whatever array you declared, array.shape will be giving you the number of dimensions of that particular array and so on. Okay. Or you can also see ndim is also syntax which you can see for dimensions. Okay. So all these things are very similar. It is just that this particular library has been using NumPy in background, and we are leveraging NumPy here to manipulate the image. If you want to see a couple of more examples, we can see like maybe uh, uh, maybe rotating the image, okay, or maybe we can see how to draw. Uh, okay, let's directly use NumPy and then do some basic operations so that you will have more idea of what we are trying to do. Okay, so let's do one thing. Uh, let's completely comment the code from. Okay, we can also still run custom lines, right, in Spider. Okay, so you can do one thing, Manju. You can say array equals to, yes, array equals to, you can say np dot zeros. Okay, you don't have NumPy imported. In line number 10, please import NumPy. Import NumPy as np. NumPy as np, yes. And now you say array equals to np dot zeros. And I hope you remember what zeros, zeros. Just yeah, write zeros, z small. The second one, yes, absolutely. Yeah. So before we go ahead, I would like to recall what this particular thing will do. So in last class also we have seen this particular syntax. So what exactly it will do? It will create a like what sample matrix with all zeros inside it. Nothing but it will create an empty matrix. So what happens if we create an empty matrix? So if we want to see that empty matrix as an image, okay, as everything, every pixel has zero, we will see a simple black, like what you can say, blackboard, or maybe you can simply say a black image, or an image with only black color, anything you want to refer to. Okay, so what you can do inside these particular zeros, start like what initialize one more tuple inside that. Yeah, you can write maybe some 500 by 500 comma 500 comma 3, 500 comma 500 comma 3. So 2 times 500 and comma 3. So what exactly we are doing here is we are trying to kind of create a empty matrix, okay, which has all zeros of 500 by 500 pixels in 3 different channels, red, blue, green, but everywhere you need to have 0. Okay, that is what I want to make. That is first thing. Okay, so now in line number 34, okay, so now what you do, let's do one thing. Yeah, let's do one thing. Yeah, CV. Okay, before we do, before we proceed further, what I want to do is simply say cv2.imshow, imshow. You show only array, like inside you just give a name to array in quotation marks and then comma array, something like you have done in line number 19. You can give any name and then comma the variable. Yeah. So now comment out line number 19 and 20 completely, or even comment out line number from 12 to 20. Comment it out. Don't remove it. Comment out. So simply select. Do one thing. Just remove those 3 quotation marks. Select all the lines from line number 12 to 20 and 12 to 20. Yes, and simply like what, use a shortcut called command 1. Command 1. Great. Okay. So now can you run these 2 lines, and you have to again terminate the console and then use this. Sorry, I forgot one more line here. Also add cv2.wait key. cv2.wait key. The line number 20, whatever you have, just copy and paste, or maybe yeah, that is also fine. Wait key in brackets 0. Yeah. So now you need to run like what, line number 10, because it says np is not defined. Yeah, or else run the total thing. That is also fine. Okay, run CV2 as well because you have terminated the session completely. You need to run from line number 9 again. Yeah, now you see that we have created a small image with all black pixels only. So what we have done, we have created a numpy array with all zeros in 500 by 500 pixels, comma, in 3 channels of RGB. Okay, so everywhere we put black. That is the reason we are only seeing black image. So now what I want to do, I want to draw a line. Okay, I want to draw a line. So how do I draw a line? Or at least in this particular, how to draw a line in this? Any idea how to draw a line? Okay, at least let's think that I want to highlight all the diagonal pixels. Okay, so in diagonal also I'll have 500 pixels. I want to highlight those pixels. Okay, with some color. How do you do that? All diagonal pixels I want to highlight with some color. Let it be green, let it be red, let it be blue, whatever. Okay, so how can you do that? Can anyone try? Or help out Manju if you already know the answer?
So is there any method called line?
We do have method called line, but I don't want to use a method called line. I wanted to I am expecting you to draw a line or maybe highlight only the diagonal pixels of this image without even using line as a method. It is simple. Okay, you already know how to highlight one pixel which we have seen in line number 15. So image 0 comma 0 equals to 0 0 0. Nothing but you are assigning a color of black to one pixel. In the same way, you have to assign one color. Maybe let's assume you want to apply red color to every pixel in diagonal. So what are the pixels in diagonal? 0 comma 0, 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, so on until 500 comma 500. So 0 to 500 pixels I will I'll have, and those pixels should be highlighted with some color. How do you do that? And please don't say that you don't know, okay? Because we have already seen so many things, and it is simple. That is the reason I always say practice things, because when you come with a real time problem, you will completely blank out. You don't know what to do. Okay, so just a hint, you can simply do it with for loop. Okay, I don't want to kind of completely give the answer, but I want to give you hints so that you can use for loop. Okay, starting with range 0 to 500 pixels, and you need to write something else which will highlight those pixels with some color. So can somebody please try? It's very easy. Okay, simple for loop you need to use. And then inside for loop, you need to write only one statement at max, and it will do the job. So is anybody willing to try, or should I just reveal the answer, how it is? Yeah. So it's simple that you can just use image of no if condition is not required. Okay, image of 0 comma 0. Okay, equals to, sorry, not 0 comma 0, I comma I. Okay, so image of I comma I equals to, okay, you want to kind of give what color? Red color. So let's say 255 comma 0 comma 0. So what exactly you are doing? You are instead of saying image of 0 comma 0 equals to red color, image of 1 comma 1 equals to red color, image of 2 comma 2 equals to red color, you are just simply assigning that number to a variable called I, and you are just calling that I inside that thing. Okay, just put these two lines 37, 38 after ARR, and then change that image of I comma I to AR, like change that image to ARR, because right now we have our image in ARR, right? Okay, that is a custom black image which we have created. So use ARR and then run the whole thing again. And just please terminate the session here first. Yeah, and run it. Great. So what it says, you just say 0 to 500. Don't use +1. Because 0 to 499 itself will become 0 to 500. And see, you are seeing what? A blue color, right? So okay, it is taking BGR as a input. Just see. Okay, so you need to kind of change it to 0, 0, 255 instead of so that it will give you red color. So just see, guys, there is a bit of small confusion. Instead of RGB convention, it is taking BGR convention. Okay, so by default, just remember this as a thumb rule. No. It is from OpenCV itself. Nothing like Mac or Windows. Yeah. You can see a red color right now. Okay. So this is a simple thing, but this can be also replicated with a simple method like as Manju already mentioned, that there is a method called line, and you can say from which point to which point you want to draw a line, and you can simply draw a line which goes by. So instead of now you can comment 34 and 35, or maybe replicate all those 4 lines, Manju, from 33 to 37 and put it down again, so that it will be easy. Copy them, put it down and comment the above. Yes. And now what you can do, you can just remove 40 and 41, and instead of 40 and 41 you can simply say cv2.line, and inside that particular thing, and you give the name of the image first, which is ARR. Okay, comma, and you have to give starting point from which starting point you want to draw a line, which is 0, 0 in tuple
So
again.
it is X coordinate and Y coordinate values.
Yes, the pixel value. The first pixel value will be 0, 0. Okay, in a tuple again, in a small tuple. 0, 0, and then give a comma outside, and the end point from which until which point, which is 500, 500, or you can take any other number. Let's take 300, 300. Okay, just to kind of see. Okay, and come out of the bracket and comma, and you can just provide any color to it. Let it be green now. 0, 255, 0. Again, that in a small tuple. 0. And now you can run everything. You can see the same thing which we have seen. Okay, if you extend it up to 500, 500, the whole line comes, as we have only put until 300, 300. So it has stopped at 300 pixels. Okay, so like this, you can do a lot of things. You can draw circles, you can draw rectangles. There are so many methods in OpenCV. You can explore. Okay, and we also have like you can also randomly do some stuff as well. Something like let me tell you one more.
Can you increase this thickness?
Yeah, you can do. You can definitely increase the thickness. So how do you increase the thickness? You have to consider more like what pixels to kind of change the color. How do you consider more pixels to change color? So you think of that. So when you are slicing, basically you have to think, how do you kind of increase the like how do you kind of increase the pixel density so that the line will be thick? You got my point?
Yes.
Yeah. So now what we can do, we will try to kind of create a, or else just after that color 0, 255, 0, can you kind of say comma and then give something called as 2, and then just can you run this and see what happens? And again, I don't remember exactly, but just wanted to check. Leading zeros in decimal number literals are not permitted. Use prefix for octal integers. No, there is some error, right?
No.
Yeah, so you got the thickness right. So simple. So the number of pixels you want to kind of increase. So you can also check with some other number, 5, 10, whatever, if you want to try.
Yes.
Yeah. So now, do you want to see one more example of drawing circles or something else, or do we kind of end it here for now? So it's based on the your interest. Whether if it is interesting, then you can move forward, or if it is boring a little, you can stop it here for now. Yeah.
So
So
basically, this line will take the image starting point, end point, and the color and the thickness, right?
yes, that's it. Yeah. So okay, it's already 10. Yes. 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 So what it basically do is right now it will actually expand the number of pixels in x and y axis by 10 more units, so that you can also highlight those numbers. So when you say 0 comma 0, okay, it will take 10 comma 10. Okay, when you say 300 comma, okay, let's do one thing. Uh, no, you are getting confused. Okay, let me do one thing. Let me. Okay, I'll just share my screen and then explain a little. Okay, so just to. Oh, sorry. Yeah. So I hope there is no issue with my audio, right? Right now, no resound and kind of. Yes. So now let's think that we have a image. Let me. We have a image like this, and we want to draw a line like this. That is what our ultimate goal. And now what we want to kind of do is, okay, let me draw a perfect thing. Okay. Yeah. I'm doing the same thing. Yeah. So let me take a minute to draw a perfect grid. Yeah. So assume that this is a grid, and when you say 0 comma 0, this will pixel will be your 0 comma 0, and assume that this is my 10 comma 10, or maybe as per our understanding, this is 300 comma 300. So now when I say unit like what thickness one only, or by default thickness will be one only. So what it will do, this only pixel will get highlighted. This pixel, this pixel, and so on. So whatever the pixels comes in diagonal only gets highlighted like this. But when I say yeah, by default it takes as one. So when you say 2 or 3, what happens is it will also take adjacent pixels. So this is your like what 3 pixels here. Okay, then 3 pixels here. So then it will start highlighting entire pixels like this. So that is what like what thickness will do, okay, to that particular image or when you are drawing a line. Okay, so so now, yeah, exactly what happens is it will start. So even though we say to start from 0, comma 0, when you say 10, okay, as a thickness, it will take 0 plus 10 and then 0 plus 10. Okay, so whole this section will be first highlighted. So nothing but 0 plus 10 until here, 0 plus 10 until here. So then 1 plus 10, 1 plus 10. So this will be your first pixel. So from here it is 1 plus 10, 1 plus 10, then 2 plus 10, then 2 plus 10, 3 plus 10, 3 plus 10, 4 plus 10, 4 plus 10. So on it will kind of accumulate the pixels together and highlight. Yeah. Okay. So this is good. So let me, Manjula, I need you back on the screen. Yeah. I'll just stop sharing my screen. Great. So one like what a little intriguing example I'll take right now to show how we can do wonders with like what this kind of abstract things. Okay. So or maybe how we can do such like what manipulation with images to kind of bring up some good outputs. Okay. So let's do one thing. Let's say. Let's remove that line statement, or maybe let's comment that line statement. Instead of line statement, let's say, yeah, comment that, yeah, and then just write in the next line for. Let's initialize a loop. Okay, and somebody can at least explain me what I am writing here. Like once everything is completed, let's see output, and then people can come voluntarily up and then explain the code, or else I'll redo that. No worries at all. Okay, so now we can say for I in range. Zero comma 175 comma 25. Okay, and inside that particular thing, just say cv2.circle. Okay, then inside the like what the circle thing, yeah, arr array comma, and just open a tuple again. Yeah, inside this tuple, just say arr.shape in indices 1. Yeah, in indices 1, floor division by 2, nothing but double slash by 2. Okay, good. Did you take it right? Yes, again give one more comma. Yes, and do the same thing again, but instead like copy the same line again, but instead of shape 1, just give shape 0. That's it. Okay, and then now what we can say, comma, like what after the bracket ends, okay, comma, then say r, then say I, because you took I in 41, yeah, comma, and then take any color. Let's take as we are using black, let's take white completely. 255 comma 255 comma 255. Okay, you can simply run this and see what happens. So what did I exactly do? So I have the code here, I have the output here. Can somebody compare both and give me some understanding what exactly we wrote? Manjula, you can show back the code so that they can and try to understand what did we write in code as well.
So what is, please define ARM shape 1 division by 2.
So what happened when you have printed image dot shape? Where did we do? We did it in line number 13, right? So when we have printed line number 13, what was the output? Did you remember what was the output? The first output was like we got a list, okay, which contains height, height, width, and channels. So first index is the height, the second index is width. So what we are doing here, height by 2, width by 2, that is what we are doing. So what will you get when you do height by 2 and width by 2? So in a image, what you will get when you do height by 2 and width by 2? You will simply get a center pixel.
Between the circle?
No, you'll get a center of the pixel. Center pixel or center of the image completely. Okay, because you are dividing the height of the image by 2 and width of the image by 2, so that you will get a number there up like what to track right now. So you will probably get 250 comma 250. Okay, let's try that as well. Can you take a line in line number 40, or maybe just can you push everything down and this? So here can you print only array dot shape 1 by 2 and array dot shape 0 by 2. Let's see what you will get.
Shape by 2, right?
You just copy that particular tuple inside 0 by 2. No, not everything. Only the shape thing. Yeah. Only, yeah. It doesn't narrow by, it is just identifying what is the center pixel. Because you want to draw a circle, I want to have a center to draw a circle. So currently we are just checking the center by this formula or this condition. Comma. Yeah, you can just simply write array dot shape 1 floor division by 2 comma, and then again array dot shape 0 floor division by 2. And just print that one line. You need to again terminate everything and then do that. If you are terminating, then you have to again run everything. One line will not be sufficient because it will forget everything, right? So yeah, you can run now. You see what you got? 250 by 250. Nothing but you got a pixel at 250 comma 250, which is nothing but center of the whole image, because our image size is 500 by 500, 500 by 2 and 500 by 2, 500 height by 2, 500 width by 2, which will give you 250 by 250. So when we take cv2.circle, okay, it's we need to draw a circle. Circle can be only drawn when you have two things. One is center and you need to have radius. Okay, so we have identified center of the circle by this particular, center of the circle or maybe center of the whole image to start circles, okay, by using line number 41. And we have used the same mechanism in line number 46 in a tuple. That's it. So now what is can somebody also volunteer for line number 45 for I in range? What are those three things inside range?
So starting, ending, and the step we have to combine.
Exactly. So starting, ending, and step. So how many steps you will have? Firstly, you will start from 0. Okay, then 25, then 50, then 75, then 100. Okay, 125, 150, 175. So how many numbers in total? How many? It's 7, right?
6. So 7.
25, 6, like 25 into 6 will be 150. 25 into 7 will be 175. Okay. So 7 circles. Can you count? Do you have 7 circles? No, no. Don't you have the image? Oh, sorry. Okay.
Yeah.
Fine. Okay, fine. You can terminate and run again. Can you check? Do you have 7 circles? You are sorry. The selection you have done it wrong. Select it from line number 9 only. The whole code. Select from line number 9. You are again missing I. Yes, absolutely correct. Okay.
Yeah. Center point dot also we need to count,
Yes.
right?
So dot also we need to count because firstly the radius will be 0. Radius 0 is nothing but simple dot. Then what is the radius? The next radius will be 25 units or 25 pixels. So you have a circle at 25 pixels. Then you have a circle at 50 pixels. Then you have a circle at 75. Then 100. Then 125. Then 150. Then 175. So okay. So that is what we have done. So we have drawn. I cannot say drawn. We have drew 7 circles. Okay. With a step of 25 pixels starting from center point 250 comma 250. That is what we have done. Okay, you can. So we have firstly created a for loop. Okay, which goes by a step of 25. Okay, and then the variable in for loop, which is I, we have passed on as a radius to the circle. So earlier, if you see for line, we have took starting point and ending point, but for circle, we have to take center point and radius. So after center point, like array shape 1 divided by 2, array shape 0 divided by 2, comma I, that is what I used. I nothing but the radius of the circle, then comma color, which is 255 by 255 by 255, which is white color. And now you can also see the thickness after 255, 255, 255. You can simply say comma, and then you can add 2 or 3 or 4, which will also give you some thickness. And you can do more wonders like this. This is just the beginning. And you can, already this is a bullseye. We have created a bullseye with simple Python code using computer vision. Okay. Huh. So you see in line number 46, I have passed that radius, which is in a variable I. After the after identifying the center point, I have passed the variable I, comma I. So what happens is first iteration, it will draw a circle with radius 0. Okay, because yeah, so which will be a small dot. Okay, then it takes radius as 25. Okay, from center point, so it will draw a smaller circle. Then it will take radius as 50, then 75, then 100, and so on until 175. So those, no, because you cannot. Okay, so you are confused with range function right now. So 0 comma 175 is starting and ending point, and 25 is the interval. Okay, the step or the interval. Okay, so if you swap them both, and you will be in trouble because you cannot make one interval of 175 between 0 and 25. Yeah, so that is what we have done. So within simple 3-4 lines we were able to do this. We can also create an abstract painting completely out of this. Okay, it's already 10:20. If people are still interested, I am ready to take that up as well, or else we can see that later. Or Yeah, I do have that. It's completely okay. Yeah. But if you people are willing to see one more thing, I'm open. Like it takes 10-15 more minutes. Like it is absolutely on you, whether you want to go ahead or just put it for tomorrow. I'm open to put it for tomorrow as well. Okay, fine. Yeah, sure. Then we'll just put it for tomorrow. Yeah, then that would be better. And we'll see a couple of examples tomorrow, maybe with rectangles, with some, let's create some abstract painting using circles. Okay. And then we'll also see some image transformation or like what, completely like how do you rotate the image? Okay. Or maybe, we'll see some more things, but I don't want to get into too much of, technical as well, because, this is where the machine learning stuff starts. Okay, we are still using NumPy and dealing with matrices only. Okay, but, the next step to this will be, predictive analytics. Simply like you have to identify a face out of an image, or maybe you have to identify an object out of an image, and so on. So that comes the later part. I will not get into there. I'll only touch, OpenCV until NumPy takes me. Okay, like wherever NumPy takes me to the further extent, and then we'll stop there. This session. So whenever you deal with or you come across machine learning things, then you can extend this learning towards predictive analytics. So that's all for today, and I'm open to take any doubts if you have.